can be configured to use C++. The version that we have here, it's a module you have to install. It's normally for Java, but you can develop a lot of different languages with it. Eclipse is even more popular than NetBeans for Java development, and we ought to install Eclipse here. All right, so an empty project, call it Lecture O, do the usual.
Well, NetBeans, I'm just kidding.
Lecture O.cpp. Boilerplate. Excuse me. For loops. Let's count from 1 to 100. Int start equals 1. Int stop equals 100. For, parentheses, int, and what am I going to call it? Counter? X? I? I'm awfully fond of using X or I as a counter. X equals the starting point. Keep running while X is less than or equal to the stop. And then add 1 to X each time. And let's just print out the number followed by a space, followed by that number squared, followed by an end of line. Or tell you what, instead of a space, let's print out a tab. So that's a \T, the backslash being the one above the enter key. I'm going to go ahead and run it. I know that not everybody's done. Just want to make sure I don't have any syntax errors.
Oh, what I did wrong.
All right, so there we go. All right, let's do something else. Let's count a variable through the ASCII table. So let's start our ASCII past all these control characters. Let's start it at 32 and keep going until 126. So for int x equals 32, semicolon, x less than or equal to 126, semicolon, x plus plus, now let's get the character out. Int space ch, or no, car space ch equals, and let's do some casting. Static cast, Python style cast. Yeah. Let's just do the old-fashioned one. And then let's print that out. And then every so often, let's put a carriage return. Like after every 20 or after every 30 or 50, 40, 50, 80, right? Anyways, so if x modulus 20 or modulus 32, that's not going to look the way I want it to. Okay, stop waffling. If x modulus 20 equals 0, what that means is if it's evenly divisible by 20. So at 40 and 60 and 80 and 100 and so on, it's going to print out a carriage return. So if x modulus 20 equals 0, C out an ENDL. And then we're going to see out one final ENDL at the bottom. Why am I doing that? So to print everything on one row until it's printed out about 20 of them. It's not going to be a perfect implementation, but I thought it'd be kind of cool to see them in a row. You know, we could even boost that all the way up to 80 or something. You know, we have a wide display. And there we go. Here's our little ASCII table. If we worked harder, we could make it display it perfectly. I think I'll change that to 80. It'll print it all in 2 lines maybe. You know what, 126 minus 32, is that less than 80? No, not quite. Anyways, there we go. There's a little ASCII table, uppercase and lowercase. What if we want to count down? We can do that. Let's count down from 40 to 30. For int, let's give it a different name. I'm tired of using x. For int counter equals 40 semicolon. Keep going while counter is greater than or equal to 30. And we're going to subtract 1 from it each time. So counter minus minus. Or you could say minus minus counter. If you use the increment and decrement in front of the variable, it's actually a nanosecond faster, but who cares? And let's see out, less than quote, counting down, end quote, less than, counter, less than ENDL. And so to go 40, 39, 38, 37, 36, and so on. There we go. It went from 40 to 30. So far, all the increments just been by 1 or minus 1. Let's increment by 10. For int I, just for fun, give it a different variable name, equals 10 semicolon. Let's count from 10 to 100 by tens. Keep going while I is less than or equal to 100. Add 10 to it each time. So I plus equals 10. Then C out less than, well, let's go ahead and use braces. I think braces make things prettier. There we go. They make teeth prettier, supposedly. C out less than I semicolon. No, wait. Less than, quote space, quote semicolon. That's to put them all on one line, with spaces between them. And so when we're done with that loop, we're going to do a end out, ENDL.
What's with the C out, then the NDL?
What I'm doing here is it's like I'm on a typewriter and I'm typing 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's no ENDL in here, so it's not going to the next line. It's all going in the same line. Well, once we're done with the loop, we want to get back to the beginning. There. Without that ENDL, the cursor would have been left right here. If I take that, is that me? The heck? Time is up. Hey, look, guys. It's a prehistoric phone.
Whoa.
Found it buried in under 10 meters of mud. No, I'm kidding. I don't know why I was doing that. It's brand new. I have a relative in a nursing home who can no longer use an iPhone. Their brain has deteriorated, and so we're getting her a regular phone. Alrighty. So that's a for loop. What if we want to add up all the numbers between 1 and 10, like 1 plus 2 plus 3 plus 4 plus 5 plus 6? So we're going to need a counter that goes from 1 to 10. Go ahead and write a counter, x, that goes from 1 to 10. But you do that part.
Type 100 miles per hour. Plus equals.
Listen, can you make the almost fine? That's I have to
Yeah, all you have to do is watch the video. If you've ever missed one, it's not a problem. Just watch the video and upload something.
Okay.
Right. So, for int, what did I tell you to make it, I or x?
X.
For int x equals 1, semicolon, x less than or equal to 10, semicolon, x plus plus. But I want to create a total or a sum. Well, in that case, I better have a variable declared above it to hold that total. And I'm going to make it a double rather than an int, although an int is a great choice. The reason why is when we calculate the average, if we do, it'd be nice to not have to worry about integer division and rounding down and stuff like that. So double space total is equal to 0, just because we're going to start at 0 and then we're going to add 1, 2, 3, 4, 5, 6, etc. to it. And then inside here, total plus equals x. We're just going to add x to it each time. So this is a classic summation loop. Then we could print out the total afterwards. Cout less than quote, total summation, can I spell? 1 through 10 is less than total less than ENDL. And if we'd been more awesome, we would have made 1 and 10 variables, right? So that we could calculate the summation from 200 to 4,000. There we go. And that is true. The summation of 1 through 10 is 55. What about multiplying? I believe that's called a factorial. Or excuse me, factorial. That's the product of an integer and all the integers below it. So 4 times 3 times 2 times 1. So we're going to be multiplying rather than adding. Same kind of business though. Double space fact. I'm just going to call it fact rather than factorial. But I better not start it at 0, because once you start multiplying something by 0, it's always going to be 0. 0 times 1 times 2 times a million is still 0. So I'm going to start it off at 1. Now it's going to look almost the same. I need my for loop, but instead of total plus equals x, it's going to be fact times equals x. So I could just copy that line. And in fact times equals x. And then Cout less than factorial of 10 is, end quote, less than fact less than ENDL.
That's okay, where L needs to be.
And notice that the factorial is very large.
Ooh.
It's 3 million at this point, and that was just going to 10. So if we made it go to 20,
it's gonna be a data overflow.
yeah, we will get a data overflow pretty fast if we keep increasing that number. Okay, 20 was to the 18. How about 30? A double can go to exponent 308, so we're at 32. How about 60? $81. How about 90? $138. That's enough, right? Anyways, it's a huge number. Let's just top it off at 100. So the summation of 100 is just like 5,000. Not exactly, but it's close. And the factorial of 100 is a 9 followed by 157 zeros. Just happens to get very large very quickly. How about calculating the factors of something, right? The factors of 10 are 1, 2, 5, and 10, right? So let's declare a variable. I don't know, just call it number.
I'm so
equals 72. And we're going to print all of the factors of it. We're going to use a for loop. And the way this is going to work is we're going to count from 1 to 72. And if the number is evenly divisible, we're going to use modulus for that. Then it's a factor. So for int x equals 1, semicolon, x is less than or equal to 72, semicolon, x plus plus. Now we're going to check. If parentheses number modulus x equals 0, if it's evenly divisible. Like 72 is not evenly divisible by 51. So 72 modulus 51 is not 0. But if it is, let's print it out. Cout less than x less than quote space quote semicolon. And then let's put out an end line at the bottom. So cout ENDL. And let's tell them what we're doing above our for loop. Otherwise, they're just going to get a string of numbers and they're not going to know what they are. First, let's run it, make sure it works. There. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Those look good. But what if it was a prime number like 17? A prime number is a number that's only divisible by itself in 1. I'm not sure I'm seeing what I want to see here. Oh. What did I put there? Did I have y'all type number there? I hope I did. And I just changed it, right? Okay. So let's see out less than quote factors of space end quote less than number less than quote r, or we could just go to the next line, less than ENDL. There. So the factors of 72 are those. I'm going to put in a prime number, 17. It should only have 2 factors. Now it makes sense to me that 1 is a prime number, but technically it's not. And I think the reason is stupid. So the reason that 1 is not a prime number is because the definition of a prime number is a number that's evenly divisible by itself and 1. In other words, that it has 2 factors. And 1 only has 1 factor, so technically it gets disqualified from being a prime number. I think it's dumb, but okay. How about 999? We're going to see a whole bunch of factors. Not as many as I thought.
Oh man.
How about 1,000?
What about 2 trillion?
Yeah, put a huge number there. All right, there we go.
Well, can you define these factors as doubles, and then that can be a way to insert the, instead of using the quadratic formula, you can use it as an easier way to skip the quadratic formula.
Right. There is more than one way of figuring out factors, and if you use an array, you can come up with a very efficient algorithm. This is an inefficient one. Why do I say, and yours would be more efficient. Why do I say it's inefficient? Because like once you get to 250, it has to try 251, 252, 253, 254, 255, and so on. And there's more efficient ways of calculating it. But we're just demonstrating for loops. I think we've demonstrated enough for loops. I think you have the idea.
And we're going what? Wait, that'll be about 8 minutes?
Yeah, we're going to stop here. Let's go look at homework.
So submit it.
I don't have a Dropbox yet, but we will soon.
I think our next one is lecture Papa.
Sounds right.
See what I just did there, Parker?
Oh, that's funny. You should
What?
tell Justin the joke.
No, I heard. There's no need for it.
Right.
All right, so homework 8, while, for, and do loops. Let's take a peek. Write a while loop that'll print the numbers between 1 and 100. Write another while loop that'll print the numbers between 100 and 1000, skipping 50 each time. You know what? Y'all are so good at while loops that why don't we use for loops for all this stuff?
Ooh, okay.
Oh boy. That is a big while loop.
And then the last one, the very last part is to rewrite part B using a do loop. I should make that part D instead. But the while loop counts, or the for loop counts from 20 down to 1. And then we will rewrite that with a do loop. So it's just a couple different ones. Pretty much just like we did. Let's modify it though. Let's make it look exactly like what we want.
I hear humming sounds. Yep, it's one of the two computers right here. You guys hear that?
Oh, wait.
I'm actually not hearing it, but my hearing is shot.
What?
Okay, so write a for loop that will print the numbers between 1 and 100. Write another for loop that'll print the numbers between 1 and 100, skipping by 20 each time. Or 1 and 1000, skipping by 100 each time. 50, just like it was originally. Alrighty. Write a loop that prints the numbers from 1001 to... We got to have at least one while loop in there, though. Write a while loop that prints the numbers from 1001 to 1020. And then write a while or for loop that counts from 20 down to 1, and then rewrite part D using a do loop. That makes sense? Good to go on that? Makes sense? All right. And let's make a Dropbox.